There are good things that friction does for you. I'll tell you, for instance, look at the bottom of my shoe. What do you see when you look there, Leslie?
I see little grips.
Uh-huh. Yeah. We call them ridges, right? Or grooves. Okay? And those things will help me to do what? Leslie?
It'll help you to walk.
That's right. Now, what would happen, for instance, if these shoes were worn down, if I had worn all of the tread off, and I tried to run down the hallway out here where you have a nice waxed floor, what would happen?
You'd probably slip.
I'd probably slip. So friction can be very positive and helpful to us, but friction sometimes hinders us. Think about an automobile. Think of what we do on an automobile that uses friction, or maybe that prevents friction. Can you think of a way you use friction on a car?
The brakes.
The brakes, that's a good example. The brakes push against the drums and help to stop the car. Can you think of a way we try to reduce friction? Think about the engine, Melvin. What do we do to the engine to cut down on friction wear? What do you put in the engine?
Oil.
Exactly right, oil. We put oil in there to keep it from wearing, rubbing it. You know, we can use sandpaper to smooth things down to make them smooth. But we're going to use sandpaper for something else here. We said that friction would affect how that operations of machines are involved. Let's see if we can try that. And what I want to do is to have you take my golf balls, and we're going to roll them around inside this little pan. Now, I'll tell you what, we'll do it one at a time. I'll let you count Melvin, and then Melvin will count yours. It'll be easier to count each other's. Okay, here's what we're going to do. Melvin's going to take the pan, and I'm going to put the tape down a little bit so that it'll stick. We have sandpaper inside. Okay, now what should the sandpaper do to the ball as it travels around, Melvin?
It should make it slow down.
That's right. Now, our goal is to find out how many times that it goes around in a period of time. We're going to use 15 seconds. And I'm going to let you count Melvin's turn. Now, Melvin, you want to turn the pan, and each time it goes past that orange line, we're going to count it. Okay, I'll let you practice a little bit just to get the feel of it going around, Melvin. There we go. That's excellent. Good job. Okay, you ready to start? Okay, here we go. All right, when I say go, you're going to count every time it goes by the red line, right, Leslie? Okay, here we go. Ready? Go. Stop.
I counted 31.
Okay, we're going to write down our first number over here for Melvin. Okay, so Melvin has a 31 on his first trial. Okay, let's let Leslie do it now. Okay, let me reset my watch. Go ahead and practice, Leslie. That's right. You got a good feel for it?
Mm-hmm.
Okay, Melvin, you ready to count every time it goes past the red line? Okay? Here we go. Ready? Go. Stop. 25, okay. And even though it went a little slower at the beginning, you'll find that if you have 5 trials, it should average out. Okay, and it's 25, right, Melvin?
Yes, sir.
Okay. Our goal is not to see who can do the most, but the goal is for you to get a regular rotation of how many times it goes around. Okay, let's go back and let Melvin try again. We're going to do 5 repetitions for each student. It takes a little while. You may not see them all at home, but that's what we're doing here. Okay, let's go ahead now. Stop.
29.
All right. Okay. Now here's what we'll do. We'll use the calculator. We'll get some totals on this. We'll add up Melvin's. Melvin had 31 plus 31 plus 27 plus 27 plus 28. Okay, that's a total of 144. We'll divide that by 5. Now this is the revolutions that we had in 15 seconds, right? Revolutions in 15 seconds. So if we took that and multiplied it by 4, it would give us revolutions per minute. All right. Let's get Leslie's, and that's 27.2. Okay, that's how many times it went around with the sandpaper in. Now what do you think will happen if we repeat this without sandpaper? Anybody?
It will move. It will go around the pan a lot faster and more.
Now, if it goes around faster, what's the only problem with it going around faster?
It'll fall out.
It'll be easier to fall out, right? You'll have to work harder to control it. So, the first time you had a chance to practice, so that you had a chance to see how good you can get. Okay, so what we'll do is right underneath it, we'll have a second set. And I'll just stay over here and start you and stop you and write it down. Okay, ready? We practiced before, Melvin. You're going to be first. Are you ready to go? Okay, ready, go. Stop.
24.
Okay. Okay, now Melvin, let me ask you a question. It was actually a little bit slower than the last time. Do you have any hypothesis, any reason why you think it could be slower?
Because I was being more careful.
That's right. I think that's true. Being more careful would affect it as well. So there's more than just this friction that's affecting this. It's the way that you are doing it as well, isn't it? So, just concentrate on getting the same pattern that you were doing, and we'll let the results come where they are. Okay, you ready, Leslie? Okay, let me get yours reset again. Okay, ready? Go. Okay, let's see if we can draw some conclusions. When we use the sandpaper, you see the number of rotations you had in the 15-second period. You had 28, Melvin, 28.8, and you had 27.2, Leslie. When we took the sandpaper out, used the smooth surface, Melvin, yours went up to 31.2, and Leslie, yours increased also to 29.8. Okay, can you think of anything besides removing the sandpaper that could have affected your results?
You were conscious you were trying to do better.
And what did you have a chance to do? You did the first 5, then you did the second 5. Which one were you more comfortable doing?
The first 5.
Ah, okay. Now that's unusual. You were more comfortable because you think you had the sandpaper? Okay. And when you had the sandpaper removed, you felt like it was going to go a lot faster, so you were more careful. Is that right?
Yes, sir.
Yeah. That has a lot to do with it. Experience is as much a factor here as the friction. But friction does play a large part.